I'm gonna talk a little bit about how we design in a world of climate change and how it has impacted some of my work, some of SOM's work, and why that matters for us as designers, architects, and engineers. A little bit of what I do. Ben kindly gave me an introduction on and I work at Skid Moorings and Merrill's New York office. And we're actually quite a big company, and we have a 84-year legacy, more than 10,000 projects around the world. We are international practice, so we have offices across the globe, and we have a opportunity to collaborate with many of our colleagues across the globe as well. And we are an interdisciplinary practice, which means that we're not just architects, but we are designers, we are engineers, we are MEP structural civil engineers, urban designers, and many more as well. And we like collaborating with each other, and we believe that this makes our projects stronger, actually. And we are built on a legacy of our firm. So every project that we do these days, we see it as something that's building on the legacy of our firm. And we have about some of these projects that you see on the screen as some of our work, and you'll be familiar with some of it as well in Chicago and other places also. And in all of this work, actually, we're quite proud of our pioneering spirit, and we like doing the first. We like being the tallest. We like being the most sustainable. We like challenging ourselves, but challenging our industry for a better world for all of us in a way. And as part of this, you know, probably some of our projects of pioneer of new capabilities, we call it. It's the tallest building in the world. Burj Khalifa in Dubai, but we are not just working at the scale, we're also working at other scales where some of them are incubator of ideas, such as AMI. It's a self-sustaining design, small design that's actually for harsh climates, let's say. But we also work with a lot of young minds and much younger than many of you. And we believe that actually we have a role, citizen architect role, to mentor others in our practice as well. So a little bit about what we do these days in our company, but also let's come to what are we going to talk about today? Why does climate change matter? And I'd like to give a little bit of an intro here on the big picture. Why does it matter? Because we are actually living in a world that's changing rapidly, but also the climate change the temperature rises have pushed the Earth in an uncharted territory. What does it mean? This means that it comes with a lot of unknowns. And we know that climate is changing, but we don't know what exactly the impacts of it will be. And scientists are working very hard to predict it, but there's still quite a bit of an unknown there. And so until this year, actually, we were basing most of our assumptions in the Ipcc report that came out 3 years ago. And it was suggesting that we actually had a 10-year period where we can curb our climate change and temperature rises, carbon emissions, to avoid long-lasting impacts of climate change. And this will require a huge transition. However, this year, a new Ipcc report came out from the UN, and this is an intergovernmental panel on climate change, is what Ipcc stands for. Basically, all governments come together and look at the research from scientists and agree certain facts. And in this report that came out this year, it suggests that what was suggested previously, the 2 degrees that was suggested previously, is already too late for climate, and we have to curb our emissions to stay under 1.5 degrees. And the other thing it did, it actually acknowledged it's the first time such a report, and governments acknowledge that the climate has already changed. So we can no longer just rely on reducing emissions, but we have to prepare for resiliency measures for a climate that's already changed, which is a big moment for all of us, I think. And what happened so far, since the beginning of the century, our temperatures have risen already by 1.5 degrees. And as a result, the extreme weather events in the last 40 years have increased 4 times. And the UN report suggests that if we continue the way we do, some of these events that are considered 100-year events, such as floods, such as storms, hurricanes, might actually become a yearly event for many of us, and particularly in certain parts of the US as well. So yes, it's changing, and it's not so many good news here. And what this also means that about 21 million people have been displaced since 2008 due to climate change related weather events. And it's expected that 200 million people will be environmental migrants by 2050. These are huge figures. I mean, if you think about it, it's a huge percentage of US population, for example, if you think about 200 million people. And the WHO, World Health Organization, identified climate change as a top threat to global health. And climate change is expected to cause approximately 250,000 deaths a year going forward, which is also quite shocking to see when we write this number down. So why us? Why, as building professionals, as design professionals, we have a responsibility? As part of the emissions, carbon emissions or greenhouse gas emissions that are causing the climate change temperature rises, 40% of those come from the built environment, actually. And many of those are the buildings that are designed, buildings that are in operation, and the cities are also contributing a big part of this. And I don't think it's going to stop anytime soon. So the global population is supposed to increase by 2.4 billion over the years. So this continuation of population growth is going to continue. And then the building stock as a response to this is going to grow about 1.7 trillion square feet, which is also huge. And 40% of this emissions come from the buildings that we're looking at. So UN has highlighted a path to zero emissions, as you see here on the screen. About 2050, we're targeting to be a net zero emissions. And many of our organizations, such as AIA, such as World Green Building Council, structural engineers, have already committed to much sooner goals to try to reduce the impact of climate change. But it's not all bad news. What's been great about actually is the Paris Agreement, for example, has been a huge achievement that many countries came together, and more than 185 countries have committed to Paris Agreement. And besides that, also cities and many cities and states across the globe have also committed to net zero emissions too. And how can we respond then? How can our designs respond to this? For example, at S1, we have two goals for every single project that we work on. One is the net zero operational carbon emissions by 2030. And the second one is net zero carbon emissions overall, including embodied carbon by 2040. And what are some of the examples that we can show towards net zero? So let's talk about the first net zero operational school in New York City, in New York State. It is actually SPS 62. It's a net zero school. And some of the strategies adopted here was reducing energy use, complementing that with renewable energy sources, designing potential for all electric, and going forward also consider renewable as offsites and potential green energy offsets as well. Although this project was able to achieve this by on-site everything. And it's a great achievement, and it's almost set the benchmark for New York City and state schools that it is possible to achieve a net zero school in our climate and in the city. Of course, many aspects went into making this net zero. It was about a combination of active and passive systems. So the energy that was produced by the building was equaling the energy consumed by the building, as well as users, such as heating and cooling, such as lighting and smart systems. And as we did this, you can see that many different strategies had to be built into it. And from photovoltaic panels to solar thermal to effective and efficient MEP systems, smart lighting, and also design of the building had to be very carefully considered, bringing daylight in to these spaces. And you can see actually that every square that you see in the ceiling here, many of them are skylights to bring in natural light into the spaces and to reduce that lighting demand that the building would have, but also using it as an opportunity for people to experience the building in a different way. And knowing that it's a net zero school, interaction between students, faculty, as well as the building was quite a key design aspiration for this project. And hence we are very proud that it set the benchmark for New York schools for carbon neutrality. But when we talk about the operational carbon, it's only one piece of the carbon cycle. So this is the whole carbon cycle. The left side you see is upfront embodied carbon, right side is end of life embodied carbon, and the middle is operational. So when we talk about operational energy, operational carbon, it's that small part that we're talking about. So as we address carbon emissions, we must think about the rest of it. We must think about the whole cycle together. And this means that we must think about materials. Where are they extracted? How much energy that went into extracting those materials? How was it transported to factories? How was it manufactured? How are we building it? Are we using fossil fuels to create that energy? And then, of course, in use, as we talk about, but also end of life. What happens to those materials when we demolish the building or when we take parts apart? Are they recyclable, upcyclable, or are they going to landfills? And all of these questions actually give our materials and buildings certain carbon values. And of course, the more recyclable we make it, the more renewable energy we use in the process, the lower carbon they become also. So the next project that I'd like to talk a little bit about is towards net zero materials. So what does it mean if you look at embodied carbon? It's the Billie Jean King Library in Long Beach, and you can see that in this project we combined cross-laminated timber and timber in many parts of the building. And because timber as a material is a low carbon material, and because of its carbon absorbing properties, it is able to absorb carbon through its life and not just become a low carbon emitter, let's say. And as part of this, in order to minimize the material use, but also in order to minimize the waste in this project, we looked very carefully about all the components that went into it. So we took a kit of part approach, and you can see here some of the parts that went into this project, and the whole project is made by the parts that you're seeing on the screen. And the idea was that, as you see in the pyramid on the left, the materiality and building configuration has the biggest carbon impact, but also has the lowest cost impact too. So we were able to minimize the carbon emissions of the materials and reduce waste dramatically. And in the design process, the planning and the design of the building is where we can make the biggest impact. So if we adopt several principles, such as building with less materials, building with intelligently, with optimized material use, and actually using materials that are low carbon, and then finally building efficiency into the systems can help us dramatically reduce the carbon emissions of a building. And those are some of the strategies that was used in this particular library project. And in this one also, we didn't just think about timber, but every detail, every material part of the building was looked at carefully to be able to reduce quantity of materials and carbon that went along. So on the right side, you see the typical wall construction versus the integrated unit at the bottom. And by just doing this, we were able to reduce material quantities significantly. And you can imagine, hence the embodied carbon also was dramatically reduced here. And it's built, and this is what it looks like. And we are quite proud of it. And we see that as designers, as we continue to push how we design, we're also seeing that cities are adopting different policies. And I'll talk a little bit about what we have in New York, but you have similar policies coming in also Chicago, for example. Our goal here is to reduce our carbon emissions 80% by 2050. And as a result, many of the existing buildings are giving a carbon cap a year and any building that exceeds that cap is having to pay a penalty. And it's a significant penalty. It's about $270 per metric ton extra carbon emission. And this adds up. So many of our buildings in the city now is looking at how can we reduce the carbon emissions of existing buildings. So this is a idea project that we did in New York City. It's 63 Madison. And how can we take actually adaptive reuse existing project, and push it towards net zero? The building looks like this today, and it is obviously of its time, and it was designed with the performance standards of the time. And we were looking at how can we take an existing building with this performance criteria and apply today's standards. So rather than actually demolishing, taking the facade out and putting a new facade on, we did a lot of different analyses of, is that better for both operational carbon and embodied carbon? Or should we look at a second skin, for example? So in this project, we were proposing not taking out the facade, leaving it where it is, but adding a second lightweight skin to it, to create a secondary thermal layer, basically, on the facade design, which will reduce the heating demand by 95%. But also we can maintain the structure and facade about 93%. So we will not accumulate those carbon emissions for the building. And of course, this was only some of the aspects of the project. And in order to get it very close to net zero, we had to look at everything carefully. We had to look at the building systems, facade design, materiality, daylight, views ins and out, and also create connections and well-being aspects, integrate well-being aspects into the project also. And what this meant is that we could bring 50% more daylight into the spaces, and we could provide every floor 100% access to nature. So we could create amenity zones on every floor that could access the amenity zones, which also works with the biophilic design aspirations we had also. And by doing so, we were able to reduce energy costs by about 40%. We were also, we think that we could also increase the potential revenue by about 35% based on the data from other projects. And this will become a net zero building as our grid cleans up in New York City. This will actually become a net zero building as we go forward, if these strategies were adopted in the building. And as we went through this process, I mentioned that we chose to overclad the building and not reclad it, which meant that we carefully considered both embodied carbon and operational carbon of the building. And we found out that overcladding is actually much more efficient for both, about 40% less operational carbon and 40% less embodied carbon as well. So the point of this is that sometimes the immediate, our gut reaction to take something out and put a new one in might not be actually the most carbon efficient result. So we have to think carefully about our designs, how we can incorporate carbon smart strategies in our designs. And this is what the building looked like if it was adopted. And then towards the net zero, the last project that I'd like to show is actually the UC Merced Campus in California. It is a net zero campus, and it is a product of a 25-year partnership with UC Merced that we had. And the idea was the campus is targeting triple net zero, meaning net zero energy, net zero waste, and net zero carbon. And over the 25 years, many different aspects was incorporated to drive towards that goal. And sometimes this takes a time. So sometimes adopting something towards net zero takes time and consistent strategies, consistent planning towards those. And this gives you an indication of what it took. And this year, actually, it was announced that it's the first public university to achieve carbon neutrality in the US. And we're proud of the 25-year legacy we had and that we were able to achieve it. And you can see that we can do this in small scale, large scale. So this is carbon neutrality is a concept we should think about at various scales, not just in a small building scale, but also in a district and a campus scale also. And so far, I talked about carbon neutrality, but can we go one step beyond? So can we not talk about reducing carbon, but can the built environment actually absorb carbon instead? So can we create a carbon positive environment rather than reducing it? So I'm going to show you a project called Urban Sequoia, and maybe you've seen it recently. It was presented at the COP26 summit. And the idea is that how can our cities go from emitters to absorbers? And cities account for about 70% of global carbon emissions. And so far, our buildings have focused on net zero architecture. But we are saying that net zero architecture might not be enough any longer. How can we absorb carbon from the air? And the provocation we had is, what if each building acts like a tree and absorbs carbon from the atmosphere? And how can we do this? We can do this by leveraging existing technologies and emerging solutions. So can we look at some of the technologies that exist outside of the building environment? Can we bring some of those into our buildings and adopt them, make them key part of our designs to absorb carbon and from the atmosphere and not just reduce it? And Urban Sequoia does exactly that. It looks at different technologies and innovation that's available, such as biomaterials, nature-based solutions such as algae, and technological advancements such as direct air capture technologies that already exist in other industries, and some of them are used also. First, looking at how can we deliver affordable nature-based solutions. We're looking at biomaterials, and these are things like biobrick, for example. And the idea is that we mix aggregates with algae or bacteria and water solution to make material. And throughout this process, during this process, as the materials crystallize, they absorb carbon from the atmosphere. And they continue to absorb carbon as well. So they can be sequestering, absorbing materials rather than something like concrete, for example, that emits carbon through its manufacturing process. And can we actually design a building that uses biocrit, biobrick, and bioplastic, and not only reduces the upfront carbon, as you see on the right, but throughout its lifetime, it actually absorbs more carbon than it emits in the process. And what else can we look at? Can we look at technological advancements, for example? And this is algae facade idea, and it basically takes algae, sun, and with the natural photosynthesis process on the facade, it is able to absorb carbon from the atmosphere and turn it into microalgae production. And in this process, it absorbs carbon directly. And the algae produced can be used as a source of biofuel and can be used in other industries, such as heating and cooling of the building. It's an alternative fuel source. You don't have to use fossil fuels. Or can it be also transferred to other industries, such as jet fuels, such as electricity generation or agriculture as well. And the last one is the carbon capture and storage technologies. This is actually, maybe you've seen some images of them. They do exist at the moment as farms of direct air capture farms, such as maybe you remember in old days we had PV farms, and that was the only way to use PV. And then the buildings started applying them in the cities, which meant that it became a much more dispersed, much more effective, and much more cost-effective system as well. And this system has a similar potential. What it does is actually harvest carbon from the atmosphere, and then it's collected in bottles, and that's distributed into different industries. And some of it is used to create materials such as carbon fiber. And can we do something similar here? Can we use this natural stack effect of the building and introduce direct air capture modules in the building to capture the carbon and transfer to other industries, and captured directly from the air. And how can we bring some of these ideas together? In our building, we're looking at mixing the biomass, such as algae, biomaterials, such as biocrate or biobrick, and the direct air capture technologies, and try to create a prototype almost for the next generation of building that is not just reducing carbon, but it's actually going beyond that, absorbing carbon from the air. And the absorbed materials such as the CO2 can be used in other industries. The algae can be used in other industries as well. For example, the CO2 can be used as carbon fiber in building industry and production of some plastics. It can go into food industry. It can be used, the algae can be used as biomass, but also can be used as fertilizer for agriculture. Can be used as jet fuel and for many and fuel source for many transportation freight industry, and also it can be source of energy as well. So rather than using fossil fuels, it can be a clean energy source to produce electricity also. And what if you were to create, I mean, let's think about a city like New York. What if you were to create a network of the systems such as air capture, biomaterials, and algae? Could we think of our cities differently? And our collection points are not simply about garbage collection, about recycling collection, but can we think of a carbon collection system, for example, to enhance absorption and our environment absorbing carbon rather than anything? And if you were to create a global network of urban sequoias around the world, imagine every city, every major city were to take a similar approach and create a network. We could actually absorb about 1.6 billion tons of carbon every year. It could be a solution to our climate challenge, and it could be our urban environment could actually be a solution to addressing climate change in this scenario. And I'm going to stop my share for a second because I like to show a short video, actually. Let's see. Hopefully you're able to see my screen still. And I'm hoping the sound is going to work. Let's see.